jump into bond valuation. My first comment is that it's easier than it looks. We did one of those already, but we'll do another set of scenarios. So first, what you need are the same things that I mentioned, these 5 elements of the face value, the term being how long the bond is for, the frequency, annual, semi, etc., the rate, which is the coupon rate. I keep using the word coupon because it's the rate that you multiply times the face to determine the amount you pay. So it determines cash flow. The payment amount is the face amount times the interest rate divided by the payments per year. So just give you some example with the math. If it's a $100 million face and it's an 8% coupon, then 8% of 100 is 8 million per year. However, if it's a semi-annual, then it would be $100 million times 8% per year, which is $8 million per year, but semi-annual is twice a year. So each payment is then half of that. So rather than get one check for $8 million a year, you'll get 2 checks a year, one for 4 and one later in the year for another 4 to give you 8 over that year. So the steps, similar to what we did in the TVM lectures, is we draw a picture. That's just a good habit. Not required, but helps you visualize the cash flow. And then we compute the bond value using our TVM calculations as we did last week. So let's look at, again, a specific example. We have a 10-year, 10% coupon bond at a 10% rate. Again, just easy to remember, easy to do. We have 2 ways to do it, and we can do it in Excel. So I'm going to hop into Excel, and we're going to do interest rates. So here, I just will highlight it. It's 10%, 10 years on a loan. The face amount is $1,000. Okay. The interest rate, I'll just write that here. Face equals $1,000. All right. Interest. If this is an annual interest rate, which it is, we will take the interest rate of the face amount times the coupon rate is 10%. And that interest rate we pay for the full term because we make no interest payments. Oops, sorry. I'll do plus that. That's easier. I'll just copy that all the way because it's identical. Furthermore, we know that the principal amount, the face amount, is all due at the end of the term. So again, the cash flows are not difficult in bonds. They're prescribed by the contract. So it's that sum, copy that across. This is just for good form. And that's the cash flow. Now the time value of money is at the yield to maturity. I'll spell that out. Yield to maturity. And this is what the investors want. So they require this, right? And so I'm going to make this bigger, format cells, and I'll wrap it, merge cells. So we see that the the investors require this rate. Now, to make it simple, let's say everything's perfect. You offer 10% and they say, fine, I'll take 10%. So here, as just a base case, is let's say it's easy. It's just that amount. PV factor is plus 1 divided by open parens, 1 plus the interest rate. Lock it with an F4, close parens, raise it to the power of years. Use that factor across 10 years. We've done this probably 10 times at this point, right? So then we do the PV of each cash flow. So it's that rate times the cash flow for each year. Copy that across, and now we have the 10 cash flows. The present value of the cash flows, and when we add them all together, is the price of the bond. This is the flow chart that we've been looking at for the last several weeks. Value equals the sum of the present value of each of the future cash flows, right? So this is a base case model that we just did, and the reason we did it with this amount of rigor is we're going to use it later on. We're going to use it as we change some of those variables. All right, so that's the base case.